I've seen you post a couple things on LinkedIn. What are you doing with I think it's Caterpillar engines?
Yeah, it's outside of what we do in the world of water treatment. The products that we have are really flexible enough to where they're used in construction, in market, in hydro testing, but they're also a great product for engine testing when they do a hot engine test. So it stops the same thing it does when you lay a boiler up using our product. That when you're doing with engine testing, you're prone to flash rust or rust after it gets drained, and we can our technology, our chemistry stops that from happening. So we were doing that. Those particular plants I was over there in England was they had been on our program for about a year, and so got to see the good things going on over there.
Well, that's cool. I would have never known that. Although I did just open up the Cortec website about 30 minutes ago, and I forgot how much was on it as far as products. And then I was like, all right, where are the water treatment products? But I did find it. So I want to start this podcast off. If you could just tell the audience who you are and what Cortec is, because I am sure a lot of them have not heard of the company. And could you also spell the company name?
Sure. First off, I'm Scott Bryan, and I am with Cortec. Been with Cortec about 7 years, the Cortec Corporation, and it's Cortec Corporation. And my background is and has been industrial water treatment for a number of years, taking care of accounts with anywhere from refineries to power generation plants to hospitals to pharmaceutical plants, everything in between. So small boilers up to HRSG type facilities from a water treatment standpoint. But I also was introduced to Cortec a long time ago with one of their products. And once you hear the name, you'll never not know where it comes from when we name some of the products that are used in what I call in the world of water treatment. Cortec is a global manufacturer of organic corrosion inhibitors. Started with a vision by the owner and founder of the company 45 plus years ago. He went to his boss working for an international chemical company and said, I have this idea about organic corrosion inhibitors. And basically the boss scoffed and said, nobody would ever pay for organic corrosion inhibitors. So he quit, went home, and he developed the process to synthesize the molecules that he had in mind, created the product, he developed that product, and then today there's 500 different products that same kind of chemistry that we referred to as vapor phased corrosion inhibitor, or VPCI. And that's in a lot of different products. We were talking before we started recording about in the manufacturing world, more so in that industry as it is in the water treatment industry. And you're right, there's a lot of people in the water treatment industry, whether they're an end user or a water treatment company, that may not have heard of us. But at the same time, once we start talking to them and they see the difference of what we represent versus the way they've always done things, that's when the fun begins.
Can you talk about that? I don't think I've heard that, the vapor synthesized.
Yeah, well, that's how the chemistry that is, the organic chemistry is, it goes through a process at our headquarters. We in St. Paul, Minnesota, where the raw materials that are brought in are going through a process where they are synthesized to create the molecule that makes it behave the way it does. When in a form of a powder, you put it in an open space, through the process of sublimation, goes directly from a powder to a vapor. You'll have heard probably in the industry that a lot of people hear of VCIs, volatile corrosion inhibitors. Those have been around a very long time. But all of VPCI products fall into that VCI category, or a family of chemistry, but not all VCIs are vapor phase corrosion inhibitor. And without going way down to the technical chemistry side of it, it's just that there are some VCIs that require something to happen, like a pressure change or a temperature or something, to make it volatilize or vapor, go from whatever state it is into a vapor. Whereas the chemistry that makes our chemistry so much different is that it requires a lower threshold to go into a vapor. And then there's a few other laws of physics that take place on here. And I'll quote them if you want. I think I at least get one on there. It's fixed law of diffusion. Our chemistry will go from an area of high concentration to an area of low concentration until it reaches an equilibrium. And that's a key function of what our chemistry does when you go into a particular application.
Kind of like how a gas works. Like a gas will expand to the container that it's allowed. Your chemistry will, like if you dump it in a tank of water on one side, it will eventually spread out through the tank of water. Is that what you're saying?
It'll go through the tank of water and also go through the air in that water, that's what makes the VPCI, the vapor phase. But this is an example of how the vapor phase inhibitors work. This is steel wool in a bottle of water. The chemistry was added to the water and it volatilized or evaporated out of the water into the airspace. And we use steel wool because if you look real close, it's got a much higher surface area than if you were just using a carbon steel panel or a corrosion coupon. This will rust within 15 minutes if you put it under normal conditions on here. This bottle was done in March of 2021. And what it shows is how the vapors leave the water, go into the airspace until it reaches saturation. Then it no longer leaves the water. So you have a reservoir of inhibitor in the liquid. But it puts a 1 molecule coating on that steel wool and has a hydrophobic tail. So it protects the steel wool against oxygen and water. And that's the secret, what we call the secret sauce in the chemistry. If I were to take this off, you don't get a rapid loss of chemistry. You're getting a slow migration trying to reestablish equilibrium because it senses a change in pressure. So consider this like if you were like in a boiler layup that uses nitrogen and you opened the boiler up that was under a nitrogen blanket. What's going to happen? It's going to be gone, right? And but if you close this back up, when it comes on, when you close that off, the molecules are still releasing out of the water until it reestablishes equilibrium, and then it stops like a light switch. It stops evolving or leaving the molecules going into the airspace on there. That's when I say this will be 5 years old. This is the bottle that I did 11 years ago. Though it's been so old that the water is leaving out of the bottle through the natural plastic. And you're like, well, it looks rusty. The water is rusty. It's because when I did this, I put the steel wool in water and waited till I saw rust. That's why I said a while ago, 15 minutes. But I added the chemistry afterwards. And within 24 hours, that surface rust was displaced off the steel wool. And that's why the water is rusty looking, and there's a little bit of iron on the bottom of the water, but the steel wool is still protected. That we weren't able to cover that when we first had our conversation, I think, but that's right there. There's a time-lapse video you can see on our website. It's a YouTube video that shows those two side by side, how fast it goes over a period of like 11 or 12 days. And I can send you that link too on there. But
yeah, I can put that in the link description as well. Steel wool, I've never thought about this. Like if you put it in water and it rusts, is it essentially going to disappear into tiny little iron molecules?
Pretty much. It'll eventually do this because right in this case right here, this is 5 years old. I had this. Is exactly what you just asked me. This is the one that's 11 years old. There's no more steel wool in there. It's just down in the bottom in the rut.
Yeah.
So you're right.
I don't think I've ever kept steel wool around long enough to see it rust. It's normally just like wipe, and then throw it away.
Well, think of like an SOS pad or a Brillo pad at your kitchen sink. You use it, leave it on the sink, and what's it going to do the next day? It's just it's a rust stain on your sink, right?
Yeah.
So same thing.
That makes sense. So, along with water treatment products, going into the importance of water treatment into a boiler or any vessel, but talking about boilers here, what is the importance of water treatment? Because I think water treatment is probably the number one killer or most expensive part of, not the water treatment part, but the damages effects of poor water treatment is the most expensive part of boilers. You see it all the time, retubes, corrosion replacement, boiler replacements due to poor water treatment, and even from improper layup. So what have you seen, just as a general overview, for what do people get wrong? Like, why is like, it seems like with all the internet and information we have now, like, why is water treatment seem to be still a mystery to most companies?
There's a couple of ideas that I have, or theories to explain that. First off is it's hard to break the cycle of this is the way we've always done it. A end user, and first of all, let me clarify one thing. As a company, as a manufacturer of products, we don't sell to the end user. We sell through a network of distributors. And in this case, we sell through almost any water treatment company out there. They have access to our chemistry that they can incorporate into their solutions that they provide their customer, which may be a hospital or a university or a power plant. Doesn't matter where. So it's overcoming the objectives that the end user, the facility manager or maintenance manager may have on trying something different. It also is overcoming the water treatment rep who may not be comfortable about our chemistry enough to present it to their customer and risk their professional reputation or their business with that customer on something that they don't quite understand. So that's the challenge of why chemistry like this might not be incorporated in there. There's an old saying in the water treatment industry: there is a worse alternative to not having a water treatment program in a facility. You know what that is?
Having a water treatment program that doesn't work?
Hey, that's right. That's exactly right. Having a bad water treatment program. That's right. Because your customer is paying for it, paying for to have the equipment protected, and yet it still fails. So where does it fail? And that has become my message. I incorporate ASME's guidelines, EPRI's guidelines for the layup of boilers, their recommendations, the consensus for that. However, I challenge those consensus procedures in a way in my training to try to show if your solution is to use a desiccant in your boilers, but if you don't basically read the fine print of a proper use of desiccants for maintaining a dry space in a vessel, if you don't dry it out first, if you don't maintain a monitoring of that desiccant during that extended period, whether it's 3 months or 6 months or a year, you have to check it routinely. If you don't, if that desiccant becomes saturated, absorbed with enough water, it'll start releasing it, and it's going to cause corrosion in the very spot where that desiccant was sitting. When you look at that and says, okay, I call that a low bar to failure. If you look at dry air being blown through a boiler, which is the second option that EPRI and ASME recommend, you think about the physics of what air is doing blowing through a water tube boiler. If you have it blowing into the one end of the steam drum and blowing it out, or maybe the mud drum and going out the steam drum, whatever parameter it works, how confident are you that you're getting that same amount of air going through every one of those tubes? It's going to go just like water. It's going to go path of least resistance. So maybe you're getting 60, 70, 80, maybe 90% of the tubes. Maybe you get 95. But what happens in those areas of tubes that don't stay dry and have that moisture? You're going to have the same effect long term as you did with that steel wool that wasn't protected. You're going to have the corrosion take place. Pass, fail, I would put that as a fail. On top of that, they're doing what they're supposed to do, but look at the energy that it takes to maintain blowing or hot air through a boiler on the water side of the tube. If you add up the energy that it takes to do that for the whole period of time, the cost of doing that solution is much higher. And what happens when somebody flips the breaker and it goes for some period of time, nobody realized it wasn't blowing air? or you were in a spot of a facility that had no power to begin with. So that's that one. The third one is a nitrogen blanket or purge. And we show in additional training that we do that why nitrogen is so easy to fail. You have to meet all the drying criteria. You have to maintain 2 to 5 psi. And if it's a large boiler, boilers normally, especially those in the field, when do they really seal off? It's as you start heating them up, and the metal starts expanding a little bit, and that's when your seals set and you get a little pressure if they set in place, right? So if you're cold iron drained and put nitrogen in there, how effective is that seal against holding 2 to 5 psi of nitrogen? I'd say it's not that. That's why the cost of nitrogen can be so much higher, because you're constantly adding nitrogen daily or weekly, monitoring it to maintain that pressure. And if you don't, then you end up having corrosion anyway, in spite of having gone through the expensive process of the nitrogen. Our chemistry was developed to replace those options. You put it in the system, you close it up. It doesn't have to be sealed. You could have a handhold and just put duct tape over it, and that's sufficient to hold our chemistry inside the boiler. And once you put it in there, you don't have to take it out. Unlike, say, desiccant, that if you don't take it out, you're going to have a really, a pretty bad mess of what happens when desiccant is, the boiler is filled and brought up to speed. And when that desiccant is going to start melting and moving everywhere. If you or your followers have any pictures of that, and they sent those to you and you could share them, I'd love to use them in my presentations. So that's where I think I went around the world to kind of explain why Cortec chemistry is an option that is easier to do. It's more dependable, less reliable in a facility, and yet it doesn't have to be removed in most all cases.
You mentioned layup, and I didn't realize blowing hot air through the water side of a water tube boiler was a layup procedure. But that makes sense. But can you explain dry layup versus wet layup and when you would do each one?
Sure. And there's the definition, or how you use those terms can vary in the industry. We developed a definition to help walk through which product we would recommend to use to lay up a boiler. So, for example, a dry layup, it means that the boiler's, in our terms, it's our definition, the boiler's been shut down, drained, opened, kind of like a annual inspection. And it's going to, you do your inspections, and then it's going to stay offline for 30 days, 60, 90 days, 6 months or a year, whatever. That kind of rolls into if it does that every year, it's a seasonal layup. So that would be a dry layup. It's shut down and left in a drained state, not dry as in going in and getting all the moisture out, just drained. I think it's a sound recommendation of any water treatment company that a drained boiler is in a much better state of condition than trying to leave a boiler full of water, especially untreated water for an extended period of time. But a wet layup is you put chemistry or preservation product in the boiler water and leave it full. And that would be the difference of a wet layup. Why would a wet layup be preferred over a dry layup? If you're in a facility, could be a hospital, could be anywhere, to bring a boiler that's been drained and left dry, closed up and sealed, but just drained, it takes it much longer to bring it into service to operating temperatures and pressures to make steam to do whatever its purpose is. It takes a lot longer to bring a dry boiler back into operation as it would a boiler that's in a wet layup. So that's why some end users will stipulate I got to have a wet layup. In cases where, when I talk about seasonal layups, and I use a hospital because they have such a redundancy of capability that in the wintertime they may need 4 out of 6 boilers. In the summertime they may 2 out of 6, but they leave all 4 off that they're not using in a wet layup, or they rotate them weekly or every other week. That again is a consumption of resources that just don't need to be used. You could identify the 3 boilers, for example, that you're going to put in dry layup, have one as a backup in a wet layup, and then able to use all those, the better layup option for 3 of the boilers that you know you're not going to need. If one boiler has to be brought online, that gives you time to bring a dry layup boiler up as well if you have to. Assuming, say, one of the 2 boilers maybe it's had a leak or had some kind of mechanical issue that had to be taken offline. So you're protecting a boiler in a way that's, you're not subjecting it to all the, the thermal, the constant heating and bringing it up and down, up and down. Water tube boilers, don't like to be brought up and down. They're designed to be running. Fire tube boilers are a little bit different. You can run them and drop, run them, shut them down, run them, shut them down. You're still going to have issues if you don't do it correctly. Overfiring it, you're going to get the tube sheet's going to start springing some leaks, and that's all based on the assumption that the water treatment chemistry is staying effective throughout that whole cycle.
Okay, so as far as a dry layup, say we're going to do a dry layup on a fire tube boiler, what is the process to do that? If I have the boiler, shut it down, it's still full of water and hot, obviously we want to let it cool off a couple days. Now the boiler's cold. How do we do a dry layup, and what of your chemicals do you recommend doing a dry layup with?
Sure. Dry layup under that scenario, fire tube boiler, we don't drive how it should be taken out of service. Our recommendation is take it out of service as whatever your boiler, following the practice of your boiler manufacturer. Each one might have just a little bit different, taking it down out of service. Our product, whichever product that might be, is used pretty much right after you've opened it up. It's cooled off. You drained it and you open it for inspection, all the things that are going to do. And then once that's done, you would, if it's a good sized boiler, I'll just say the boiler lizard would be the first product. And the boiler lizard is a powdered product that is packaged in a polyvinyl alcohol water-soluble bag. It's about 3 feet long, about 3 inches wide, and it looks like a big sock. A lot of people call it a sock, but the boiler lizard is designed to, if it's a fire tube boiler, you get from the top of the boiler, you lay it down across the top of the tubes, and then you cut it open on the top, kind of like a baked potato. You don't mash or anything like a baked potato, but you just cut the soluble bag so that you're getting it directly exposed to the air, so that sublimation process starts kicking off like that. You put 1 boiler lizard for every 1,000 gallons boiler volume. If you have a 200 horsepower fire tube boiler, rule of thumb, I learned this a long time ago, and I went through a series of talking to different boiler manufacturers, and it's pretty close. There's some nitpick numbers a little bit off that you from a rule of thumb, but about 5.25 gallons per horsepower would get you pretty close to the full volume of that boiler, of a fire tube boiler. So a 200 horsepower boiler should have around 1,000 gallons. You would take 1 boiler lizard. If you have a 400 horsepower boiler, then that's 5 times 4 gives you about 2,000, 2,200 gallons roughly. And if you're shutting it down for less than a year, then 2 boiler lizards would be what you would lay down on the top of the boiler. If you have a small boiler, let's just say it's a 75 horsepower or 100 horsepower, but it's so small, maybe like a Miura boiler or some of those vertical boilers where there's not really a access big enough to place that 3-foot long lizard in. We have a product that we introduced a few years ago. It's called the Boiler Gecko, and the Gecko is in a non-aerosol spray can. It's a chemistry, a liquid chemistry that's in the air bladder, so that 1 can will treat 100 gallons of boiler volume. And they come 12 cans to a carton. Effectively, 1 carton of the Gecko would treat around the same amount that boilers would do. There's a little extra on there. But you would just empty the contents inside the boiler. There's a You can have an application extension on it where, snake that up through a valve or sight glass or something where you can empty the contents in there. And that's basically, when you do that, you close it up and that's preserved.
Can you put too much in as far as the gecko or the lizard?
You would have for it to work or not work. No, it would. It would just from a cost standpoint. It would be. But to have it, the only time, and I would say the closest you would overdose it. Say you had a 1,000 horsepower boiler, and no, a 200 horsepower. Let's go back to original example. 200 horsepower called for one boiler lizard, and you decide I'm going to put 10 boiler lizards in there. The only thing that you don't stop the chemistry from working, but look forward to the day that when you're going to fill the boiler up, and you got to have enough water that as you fill it up, that powder is going to go into solution quickly. It goes into solution under normal dosing and everything very fast, within minutes. It's kind of like trying to take a cup of sugar and put it in a glass of cold tea. You've exceeded the solubility, and you could have that. Is it going to hurt it? No. Will it eventually dissolve? Yes. But that's the risk of just having an impact to that solubility part of it, temporarily or
Right.
otherwise.
Yeah, I'm sure most people aren't going to do that. But if they're like, oh, like one, maybe enough, maybe 1.5, let's just put 2 in there. There's no drawback to that.
No drawback on that. In fact, if you had a 20, like in the case of the 400 and it's 2,200 gallons, and they say, well, I'm going to lay it up for a year, maybe longer. I would actually bump that to 3 boiler lizards then. Just to be on the safe side, just be on the conservative side of making sure, because in the case of something being up that long, chances are it's going to be opened up. Somebody's going to open something up or whatever. And if they open it up, you lose a little bit, you close it back up, you've got enough product in there that's still going to replenish and reestablish that equilibrium on there.
Is the product, like, I think of like SDS at places like, oh, if you bring in a chemical product, you got to have an SDS. And then you're saying that it goes into the air inside the boiler. Like, is there like if I open up a handhole, do I need to be wearing a gas mask or anything like that?
No, normally not. You don't. If you were to go into a boiler, actually physically go into the boiler that's been dosed with it, first off, you would have to go through. I would think you would have to go through the normal confined space entry permits that would blow air through it, gas it out. You don't have to remove the product, but you do want to put fresh air in there because it's going to be concentrated space. It's not a poison like it would be if you were nitrogen or something that would asphyxiate you, but you could have sensitivity to it. So you would blow the air out. Or get air current out of there. If you have to do a lot of work on there, we would recommend removing the boiler lizard. You can take a heavy duty shop vac, pull all that out. If you had to go in there and say retube a boiler type of thing on there, but it's not a SDS normally. Referred to, there are SDSs that come with that, and we'll also have other handling procedures to go for that.
Yeah, I just imagine chemical companies saying, hey, we're going to put this chemical sock inside, and then it's going to distribute in the air, and then the next question is the manager or the safety person saying,
that's right.
All right, well, when my employee in 3 months, 6 months wants to open up a handhole and we're going to inspect it, what is the procedure like to, like, kind of like if you're pouring muriatic acid, which is hydrochloric acid, you like get vapors in your face. I didn't know.
Absolutely.
I didn't know if there was like, hey, you pop open a handhole and you need to shine a flashlight in, like if there's any like that you should have a fan blowing or something, or if you're like, oh no, it's fine in like very, very low concentrations because there's no active movement of air through the boiler in that point.
Right.
But if you left open the handhole, it would start coming out eventually very, very slowly.
Yeah. If you let the handhole open, it's not going to rush out. It will leave at a rate of the diffusion process and or any air current that might cause it to do it. I can give you an example. One hand, I got a call from a hospital one time in the mechanical room. They had laid the boilers up with the lizards, and then in the mechanical contractor had come in to do something with one of the boilers. They opened up the handholds and the manhole up on top and left them off over the weekend. And they came back in the next, that Monday, and operators were smelling had this odor in there, and it was kind of you could smell it. It's not aggressive, but you knew it's something. And they found that. So the call was, did we lose protection? You didn't lose protection in the system. If you put the cloak back up, there's enough residual powder and everything in there that would reestablish for that short period of time. But it did illustrate just how effective that product is going to go from an area of high concentration of load. It was seeking to create a preserved state in the mechanical room, but it wasn't something that people had to rush to the hospital or had to come in and blow air out of the space on there or anything like that.
That makes sense. So if I am going to lay up a boiler for a year and I put the boiler lizard in, do you have a recommended inspection intervals? Because most people are going to want to know or find out, like, is the product working before you open up the boiler a year later and there's rust?
It didn't work.
Yeah.
There's a couple of ways on that. And we have been doing, the boiler lizard's been around for, it was one of the first products in the water treatment industry introduced something years ago or longer. We've just had cases, repeat applications with, once they see the results that it works, it just becomes part of the maintenance. With that aside, when we do seasonal layups, you could do, I look at a difference between a seasonal layup, something less than a year, versus something more than a year. If you go more than a year, like 2 years or longer, that's no longer a seasonal layup. That's a mothballing a piece of equipment. And anytime you can use the same chemistry, but our approach is going to be a little bit different. A mothball, I may not use the boiler lizard. I would use something like the gecko or the bulk equivalent of the gecko, which is the boiler dragon. I would fog that liquid product in there. So, and then we recommend implementing what we call a corrosion monitoring program. Anywhere you have handholds, you could hang a corrosion disc or a coupon. And when you just open the boiler up to where you have it, take that disc, take a picture of it and record it in your report, and then put it back in there and close it up. When you don't see corrosion on that corrosion disc, you know the chemistry is working. If and when you start seeing corrosion on that disc, that means the chemistry is no longer working. And that could be explained by being left open, or you crossed over from 12 to 18 months, 18 months to 2 years. We say the lizard, for example, will treat up to 12 months. We know it'll treat longer, but we don't want a customer to go from a seasonal layup into a mothball without knowing what the other prudent monitoring recommendations might involve on there. And it could be the water treatment company doing it. It could be the boiler maintenance company coming in and doing those things. But just that information alone will help do that. And if they want to do that every 3 months, look at a coupon, make sure, that's something you could do as well.
And as far as a layup, do you recommend or have any experiences with like the fireside? Because I know some boilers can have, if you're not careful, they can have some pretty good draft through them when they're off, and that can bring around a lot of condensation. Do you recommend layup procedures on the fireside as well?
Yes, we do. And the chemistry that we talk about, the water side, works just as well on the fire side. Now, the one thing you got to do is you have to close off that exhaust stack, so that you don't have the air moving in and out. Because if you did, then it's just going to carry the treatment product away with it. And so there's ways you can put a temporary flange or covering the top. For every example I give on how to do it, the folks at that facility are going to come up with a better way of doing it. Usually I just say, you just want the air not to move on the inlet side with the fan. Usually the blower is enough to not keep air going through there. But if it's, like whether it's a fire tube or a water tube. But absolutely, we do. We recommend procedures for laying up the fire side of the boiler anytime that's an issue. Especially if you think about HRSG units with those fin tubes, those are so prone that they'll rust in a New York second.
How do you calculate it for a water tube? Like, I don't know, a big water tube boiler. I haven't looked at the manufacturer of a custom large water tube boiler, whether they spec like how much air space is in the boiler. How do you calculate? Do you just rough it?
You basically take the dimensions of that firebox and the whole airflow, and as high up as wherever you're going to be able to flange off or close it off. Calculate that. Basically, you can say rough it. You figure out what that volume is, and you're going to fog that in based on the cubic feet. When I mentioned the gecko earlier and said 1 can treats 100 gallons, I didn't give the true dosing rate. The dosing rate on that is really anywhere from a half a fluid ounce to 1 fluid ounce per cubic foot. That's the true dosing. So when you look at the fire side, and you can do it for a year, you would put 1 fluid ounce per cubic foot. And once you've established what that volume of that internal space, regardless of the tubes and passing, you're just taking the volume. And then you calculate that into how many gallons you're going to need to spray that in.
When you're spraying that, I don't know what it looks. Does it literally look like? Is it like foggy air chemical? Can you see it?
You can see it. You can see it. I was involved with a mothballing of a trash burning. That's not what they call it, but it's a power plant. They use just wood and everything else. And when we were fogging it into the steam drum, we established an industrial size shop vac down at one of the lowest drains below at the low end of the facility on the ground level. I was about 120 feet in the air, and down there underneath the surface condenser, we just put the shop vac on there. As we were fogging it in, later, after we put the amount in there, we went down and I broke loose the shop vac, and that had created just enough of a current that you could see the fog. It looks a little cloudy, like a fog mist that was coming down through that drain. So we knew we had gotten it all the way through that system on there. So there's some tricks to the application. So the more involved a boiler is, this boiler design, then you look at different ways that there's tips for applying the product. So you might have to do more than one location. Sometimes it'd be 4 or 5. One of the things we talk about too is don't just look at the water side of the boiler in any boiler application. You know, what is going on with the feed water tank or the DA tank, condensate tank? Do they want, if it's going to be down for a long time, should they consider doing something with the feed water line or condensate line or even the steam line and other heat exchangers out there? We look at the total preservation of the system and not just the water side.
Is there a way to know? So I've calculated I need so much of your fogging product. Do you just add it all and then trust it's full? Or like, is there a way to know or inspect that you've calculated correctly the volume?
There's not a direct measuring of some products. The others, there is a like in the boiler lizard, there is a it looks like a pH strip that you can put into the vessel, and it measures it says it's present. Doesn't tell you how much is in there, but it's present in the airspace. And then we're always looking at ways to try to verify that. But just through history of when you know you fed it in, and you've, like in the case of a water tube boiler, large one, and your plan is feeding it on the one side of a steam drum, and on the opposite side, you open the mud drum, and that's where you've got a fan pulling the air. Once you see that mist coming through, you close that off and finish that concentration. You know you've got enough in there because just of the dosing recommendations that we do. The only time when it really gets little maybe tricky if someone's trying to cut edges. And, if our recommendation is 0.5 to 1 fluid ounce per cubic foot, and someone wants to get in there and just go to 0.1 fluid ounce per cubic foot, the key is to have enough of that material in the airspace that it's going to continue to diffuse. And if you underdose it, it may not diffuse all the way out to the right amount through the whole system on there. But when you're seeing the fog coming through on the other end, I mean, just through years and years and years, we've known we're getting the right amount. Not having so we don't measure that part of it chemically, but it's the same thing. You could still put the coupons in or corrosion disc in, and no, it's not how much chemical you have. Is what is the amount of chemical doing for you, and that's what we just show that through the monitoring side of it.
And on a large water tube boiler, you would use the fog on the water side and the fire side?
Sure. Yes.
Okay, so then customer's ready to start the boiler up. Do they just blow the fog out, or?
There's no need. Once they fill it up with water, and as they're filling it up with water, the normal startup of a large boiler like that is there's a lot of steps involved, right? Before they actually send steam to wherever it's going, be it a turbine, being into a plant for heat exchange processes and everything. By the time that chemistry or that boiler is filled up with water, the concentration of that product in the water has dropped really low. At the same time, if they vent as they fill, because they've got to get that air out of there, well, they're pushing a lot of the vapor phase portion out. And once they start bringing it up, heating it up and firing it up, and they're bringing that up to operating temperature and pressures, the chemistry that was fogged in there is thermally decomposed. So you're not having a residual of the chemistry around anymore.
What about boilers that have steam with direct contact with product, or even like food? Is there concerns there?
Well, our Dragon, we only have one product that's being released actually at the end of here the next month, is for a wet layup of boilers that require NSF G6 certification, which is direct injection into edible food. We worked to develop that product specifically at the request of a customer who wanted a wet layup in a food plant. For that same reason, they want to be able to bring it up very quickly. But and they wanted a better way than using the traditional wet layups like sulfite, and you put a 200 ppm of sulfite, jack the alkalinity up, and that's been the recommended wet layup procedure since the 90s. Last reference I saw. The thing is, go back to, I'm answering the question. I'm just going to come back why this is different. When you have a wet layup using sulfite and the alkalinity, it is incumbent on that operator to test 2-3 times a week, possibly. Water treatment reps should be checking that. Because if you don't check that sulfite level and it starts dropping below, and you having some oxygen incursion for whatever reason, that oxygen is going to start causing a reaction, rust, corrosion, and pitting. Even more is that boiler is left at normal water levels, and you have that airspace. All the sulfite in the world is not going to take care of that airspace. And if you've got oxygen coming in, that's where you're going to have the corrosion taking place. So our chemistries are for wet chemistry, our wet layup with the NSF G6. You put it at normal levels. You don't have to monitor it as frequently because you're not dependent on a sulfite level, but you're having that VPCI chemistry reaching through and going up into the airspace, just like that steel wool earlier. You're protecting it all 3 phases. And then you don't have to drain the system out, down to bring it back online, which defeats the whole purpose of a wet layup. Now, if you're using the Lizard, which the boiler Lizard is NSF G7, you can use it in a food plant where the steam is not directly injected into edible food, then the G7 does not need to be removed. There's 2 other options if you're doing the dry layup with the Lizard in a plant that has NSF or FDA certifications required, is you go in there and remove the boiler Lizard, or you fill the boiler up and drain it and then fill it back up again. That's extra steps that says, well, that's kind of an extra step, but you're getting the benefit of the layup, the full benefit of a dry layup, but you're actually taking an extra step to remove the product. And I would submit that that's no different than if you were trying to use a desiccant to put in there. You got to go in and remove the desiccant. And if you don't want to go in there and remove it, just simply filling it and draining it and then filling it back up again, the boiler lizard product is gone. It won't be in there. So
the sock material and all the powder is made to dissolve, not leave any residue on the metal
that's right.
It contacts. And if you drain the boiler, it'll be 100% gone. And then you refill it, and you essentially should have a clean boiler that's been protected from rust.
That's right.
And corrosion. All right. And in terms of corrosion for closed systems like hot water boilers, do you have any products for that?
We do. There's another animal. There's another reptile that would have to put in there. There's 3 different products that we would use in especially in the hot loops that are depending on the type of closed loop that you've got. We've got a few different products for closed loop systems. Good thing about it, one of the things we promoted last year, brought out, was after a field trial was done, which is show how effective our chemistry is during an operating closed loop, so that compared to the traditional sodium nitrite borate or molybdate or silicate kind of programs. So if you were using that while it's operating, it's so much easier to put it into a layup mode, because you might just top off the dosage that you had in there. Development, or one that we've been promoting for a couple of years on there. We have all the field studies and the cost evaluations of the two. But let's just say somebody's not using it for their operating system, and it's a hot water boiler, non-steaming boiler, and you wanted to shut that down for the season. You could add the liquid product to it and circulate it and shut it down, and that's considered a wet layup, and that works for that type of system. Very similar to what it would do in a chill water system or the condensing water of a cooling tower system. We have a product different products are designed to go in each of those different kind of systems, whether it's boilers, non-steaming boilers, chill water systems, or hot water systems. They're compatible, whatever the chemistry is in it, and you don't have to remove it when you bring it back online at some point.
All right. That makes sense. Going back to the steam boilers, I was just thinking about, is there any concerns about, say we have a water tube boiler outside, we drain it, fog it, and we're going to put it through, I guess, 2 years, we're going to keep it off, and we're in a cold climate. So it gets cold, it gets warm, it gets cold. Is there any concerns there or extra precautions for the boiler that's going to be negative 10 degrees, and then in the summer it's going to be 80 degrees? As far as having to treat it?
I would go, and for how long was this going to be for? A while, more than a year, 2 years.
Yeah.
Well, that to me is where the corrosion monitoring, the disc, would really play in a factor, because those swings in the heating, especially a hot day, cold night, even if you did that over a spring, going from one, may not be a true leak, but there may be the shrinking and slight contraction of any opening or seal. You might lose some of the chemistry just through that extraction and contraction of going in the system on there. Having it. So one is, for the longer system, you would go with a higher dosage. So it gives you longer before you lost so much of the chemistry that is no longer working in the system. And the second thing is, if you start seeing the corrosion disc, maybe monitor that every other monthly or every other month. Seeing that during the springtime like that, once you've reached a stabilized operating climate, they're really not going to see that much change from a contraction, expansion of the boiler openings. But that's not good. But that seasonal changes doesn't hurt what our chemistry is going to do inside that boiler. Yeah, I would do that during that 2-year period. Yes, just to establish the baseline, show that you have it. it's good. And so you don't come after 2 years and open it up and find the disc is corroded and you have some corrosion inside. Where if you had done it, in the first month, you might say, "Hey, we didn't get a good seal here. Something's still open." You might find a handhold that it didn't get closed up or left open on there. That's Murphy's Law. That's going to happen. And the other area of concern might be are there any areas of that boiler that might have water remaining in it that you had to be careful about freezing? Our chemistry is going to stop the corrosion, but as it is, it won't stop. The first thing I think about is non-drainable superheaters. If you have water sitting in them and it gets to really cold temperatures outside, you got to be careful about what's going to go on with that. So there's not a whole lot of options on there, but I look at boiler manufacturers to say, what do you do to protect that? Do you try to inject it with some glycol, or do you try to get in there and remove that water through some other means? And that's a little bit beyond the scope of my experience.
How long have you seen a boiler laid up and then brought back?
We have case histories of where they've been laid up for years. I don't know that I've had, maybe around a year, a little over a year. The difference is that I'll get involved with our distributors, whoever's working with the company, whether it's a mechanical contractor or a water treatment company, and we talk about this on the upfront, but I don't really ever get notified about the boilers coming back into service later unless there's a problem. And I've not had anybody. I've gotten involved with different power plants that they were going down for 18 months because they were doing a major outage and turnaround, different retrofit or whatever they were doing. And we treated the fire side, water side, and all of that was done. I don't get feedback that says, well, it didn't work or we have problems. And I think we would have, so.
Yeah, nobody ever calls and says how amazing your product is when everything goes right.
That's right. Except for the folks at CAT, when we started talking about a while ago with the engine testing, they told us the product worked great.
Do you have any horror stories about? I know you mentioned other methods of layup, blown hot air or nitrogen, that like you've been called in or had a rep to call you or something to consult. Like, hey, they turned off this boiler for a year and then they thought they laid it up correctly, and then now they open it up, the corrosion coupon is corroded or something. Like at that point, like one, do you have any stories? And then two, like what do you do if you found out that somebody didn't have the correct layup? How do you save that? Is it just you got to replace everything, or like is there a way to save and try to reduce that corrosion?
Well, there's a couple of ways to answer that. I'll start off saying one approach is you take a great product and apply it incorrectly and get bad results. An example of that was that an HRSG unit was being laid up with the recommendations at the time, our recommendations, using a powder of a product that is blown in there like using a shop vac. 20-something years ago, 30 years ago, that's the standard practice. It's still effective for different types of applications, different pieces of equipment at different periods of that equipment's life cycle. In a boiler, it's a little different, especially for long-term layup. The thing that took a good product and made it a bad application was they put a product in there that it was not designed to go into a high-pressure boiler. It had silica in it as a anti-caking unit, but it was clearly listed on the product, clearly listed on the product data sheet, on the safety data sheet. And yet the decision was to use that product, blew it into the boiler, and when they brought it up, the silica numbers as they brought the boiler up was creating all kinds of problems. And so that's a horror story of using a good product in the wrong application. Another one is where I was involved with the mothballing at a refinery they went through the process to do a layup of the cooling water system because there was a lot of different heat exchangers they wanted to protect and on that. Or the boilers, however, the decision was, well, we're just going to leave them open and let them stay dry. Well, in that part of the country, they don't necessarily stay dry. The humidity is enough and the seasonal changes that when they looked at them 6 months later, there was a lot of rust going on. Could you make the decision, we're going to put something in there now to stop it? We could put it in there and stop it from getting any worse. Or they go through a cleaning process, but that was beyond the scope of what we would typically get involved with. That other companies would come in to do that. Once they cleaned it, we might come in and then offer a preservation of it. And then there was an application. I guess it was in South America where they chose not to lay it up, do anything, and then maybe I don't remember the exact details on there. They either change in management or change in ownership. They came in about a year later, saw what it was. They wanted to go in and conduct an online cleaning, acid cleaning of some type of rust removal, and then to lay it up. So it's when you start talking about the layup of a product and you use the right product for the right application, the cost of that chemistry, it really is that, penny wise, dollar dumb, or pennies on the dollar to fix the problems, because can it be expensive to lay a boiler up? Yes, it can be, depends. But if that is avoiding the expense of retubing a boiler, then the cost of laying it up pales in comparison. Or what happens if that boiler fails in the middle of operations and you blow a tube or you have something else fail? Denial of services to whatever that steam is going is one thing. The cost of shutting that boiler down is another. The threat of injuries because of that boiler failure is even worse nightmare. And then having to bring a temporary boiler on site to make up the steam that boiler is not going to be able to make. The cost of all of that would be a magnitude higher than it was just to simply lay it up the right way to begin with. I have a project this year, and it may be something that you or maybe some of your listeners would want to be involved with, and we could collaborate. I would love to see projects where a boiler was not laid up, and what the cost of that decision was at some point. It's not going to fail after the first year, but anytime you see a boiler tube failure, water tube with oxygen pitting, I'll wager it's rarely ever due to the operating times, because when the boiler's operating, you have somebody dedicated to make sure the chemistry's there. I meant to say this earlier, was that EPRI and ASME, so the majority of boiler tube failures are a result of poor layup practices. And that's the case of doing it. So it may not fail this year, but it might fail next year or the year after. And so the developing a way to say, if it costs you $2,000 to lay your boiler up, for example, and that's a big number for me when as far as what it would take for the boiler lizard, for example. If it costs you $2,000 to do that, but yet you're saving or avoiding, $100,000 on there, who would not make that decision to spend that $2,000? The most of the time it's because, well, we've never done it that way, and so they think that they're the guinea pig. Well, we lay up thousands of boilers every year through our distributors. But if we say we did 10,000 boilers a year, how many boilers out there? 10 years ago, 15 years ago, the Department of Energy came out and said there was like 600 and something fuel-sized boilers in the United States. That's a lot of boilers. I think there's a lot more. That seasonal layups are not being done in a way that protects them the best way.
That makes sense. Yeah, the tricky thing about water tube boilers is when you have corrosion, it doesn't just like corrode one tube and then go to the next one, go to the next one. It's a little bit on all of them.
Mm-hmm.
And even if you do get one bad tube, it may be on the inside of a bundle and you have to remove 10 tubes in order to get to it. And you've already pulled off the whole side of the boiler. And like, it's no like just On a fire tube boiler, it's a little bit more like, oh, we could pop it open, pull the tube, put a new one in. But a water tube boiler is very much more involved. And when you corrode, the trouble thing, with having a bad layup or even bad water treatment, once you start corroding those tubes and they start popping, during operation, at a certain point in time, you just need to bite the bullet and do a full retube. And a full retube on a water tube is going to be 6 figures plus, depending on the boiler size. And I imagine, I don't know what the actual number is to do a proper layup and have proper water treatment, but I always know it's less than a full retube.
Oh, yeah. But
I would think rarely companies do the both. Like when you make the comparison, of course we would have proper water treatment and proper layup procedures. But I think a lot of it just comes from, yes, we've always done it this way. People are scared to do new things. And it's also, it'll be fine because we can't see it. And like, that's, I think the explanation of most boiler problems is, oh, it'll be fine. We can't see it. Like if you could turn the boiler inside out and see that corrosion happening every day, they'd be like, why is it corroding? Like if you go out to your car and it's just like turning rusty every single day that you park in a parking lot, you wouldn't be like, oh yeah, we'll just wait another year and try to fix that. You'd be like, why is my car rusting?
And you want to take steps to fix it. I spoke at a boilers user group a couple of weeks ago. It was a mechanical engineering group in England. I think I've told you I was going over there. And one of I was able to sit in on the other presentations, and they showed exactly what you just said, Eric, about the one tube. In this case, it was it was a tube failure, not from layup procedures, but it was the soot blowing to knock off the deposits, and that over time cut into the metal of the tube. And when it started blowing steam, it started cutting into another one. But in order to replace that tube, you're taking out multiple tubes. If it was within the first depth of the tube, that's easy. But when you get a foot back into those downcomers or the generating bank, that's a very involved process. And the same thing can happen with the poor layup procedures as well.
Yeah, and the tubes are not go to Home Depot and buy a tube.
No.
Especially on a larger boiler, they're probably custom bent, custom from the manufacturer. You'll call them up, and they may have one or two in stock, or they go, hey, yes, we'll get you tubes. It's going to be a month and a half. And then you're wondering why the boiler startup is all delayed and retube is delayed because you can't get tubes. And it ends up being a very, very messy process. Hindsight is 2020. And, oh, man, if we only would have laid it up properly, then none of this would have happened. Yeah.
We have a really good case history. Again, it was done with one power plant that had two combined cycle plants being laid up for 2 years. They used our technology for one, and they used nitrogen for the other. It turns out that the things I kind of talked about earlier about if you don't have a good nitrogen, if you don't have a good seal with the nitrogen, that ongoing monthly cost, if you add that up for the full cost of 24-month layup, the VPCI chemistry was this was in pounds, but just it doesn't matter if I use pounds as a measuring or dollars, but it was 3,000 pounds to lay the unit up, one unit up, the initial cost with no additional cost. With the nitrogen, it was 2,000 pounds to initially charge the nitrogen in that other unit, but it took an additional 2,000 pounds per month for the 24 months. So when you looked at the true cost of one option versus the other, it cost 50,000 pounds to use nitrogen for 2 years as opposed to 3,000 pounds for the VPCI. That's a very powerful comparison to show the difference between the two. But that's where we get involved is if someone wants to evaluate that or look at options or why would you use one product over another? Every plant or every boiler that's going down might have enough of a unique difference to it that it might make you sway to go to one product that we recommend versus another on there. But that's where we come into play to provide that kind of recommendations and advising both to our water treatment companies as well as to end users.
Earlier, you were saying that you were going off the recommendations of ASME, and then what is the second organization?
EPRI is Electric Power Research Institute.
Okay, I'm not familiar with them. I'll have to look it up.
They've been around they've been around for, I don't know how many years they've been around, but it's an organization that members, usually it's power generation plants on there. But they have the paper out, and then I have it somewhere, a hard copy of the consensus for laying up boilers. The ASME has that book out as well. And so I went through and read that's what I've done when I developed my approach on why is VPCI chemistry different. Yes, I'm biased, but why is it better? And it's better for a lot of different reasons, but it's the fact that it's more dependable and less likely to fail, even if you do everything right on those other approaches.
Yeah, I would say that most contractors or water treatment reps, not that they're dumb, but the education level is pretty low, and they don't want to spend all this time trying to figure out, are we laying up this boiler properly? Are we not? What's the margin of error and all this stuff? And if they know a product works and the directions are very simple and it's, hey, this is how we need to do it. All right, great. And then there's no constant monitoring process or hey, if you don't do this, it's going to fail. You can do the corrosion coupon and everything to check it. But, with nitrogen, it's easy to add nitrogen and somebody thinks that you're done, and then it leaks out or loses the charge after 3 months or something, and somebody may not be educated enough to know that you have to keep up with it or some other way. So the easiest process to lay something up with the least likely amount of failure is the best process, as long as the application is correct, because you just want to remove all the variables of failure that you can engineer out of the equation. And a lot of those are humans lacking knowledge and also managerial. Like a contractor can say, hey, we lay this boiler up with nitrogen, but you need to fill it once a month. Are you going to pay us to come back and do it? Oh no, we'll do it. And then a year later, the contractor finds out that they didn't do it. It's like, oh, okay. But then they look bad a year later because the boiler layup didn't work.
And there's another thing to consider about a boiler that's being laid up with nitrogen, and especially if that boiler is indoors. If that nitrogen has to be replenished daily or every other day because it's being lost, you need to ask, where's that nitrogen going? Because nitrogen is heavier than air. That's why it's able to displace the oxygen. It just moves the oxygen out and creates that inert environment. But it wasn't that long ago, and you can go back and Google searches where nitrogen was used in a boiler room when it was constantly leaking, and it accumulate down in the pit where the pumps and other pieces of equipment were. Well, that nitrogen accumulated down there to such an extent that if an operator goes down, is not aware of it, they go in and they'll die because they'll not notice the nitrogen has already, they'll fall out before they're able to get out. And it just becomes a cascading effect. And that's the worst part to me. Having some corrosion in a boiler, okay, you can live with that, right? Or you'll pay for that part of it. But to lose somebody because the nitrogen wasn't being monitored, somebody griping about spending $1,000 a month on nitrogen ought to be saying, where's that nitrogen going? Is it creating another problem that's going to be even worse than the cost of the nitrogen in a boiler room? And I hope that I've never been personally involved in something like that. I hope I never am.
Yeah, I've seen a lot of those in boiler rooms, like steam tunnels or connecting tunnels, pits, return pits, condensate pits, and a lot of operators. I mean, I've rarely seen atmospheric monitoring systems down in those areas, and I guess, nobody really thinks about it
until it happens. Yeah.
It's invisible and it's not really a confined space. So there's no like, oh, to climb down into this giant pit, like that's a normal process, or to walk through this tunnel, that's a normal process. But if you are releasing a gas that is heavier than air, it floats to the bottom. And, if you could, I guess if you could put some kind of coloring in that, you would see this slow layer of gas just floating along the floor and pouring over into the pit. I know there's been representations done with like, because it's hard to imagine, but if you pour it, you can pour like nitrogen into like a glass, and then you like pour it out over a flame, and the flame goes out. But it's weird because you would think that nothing's in the jar, but like there's nitrogen in the jar, and you just think that always gas just expands, but it's held in the container because it's heavier than air, so it sits down. Yeah, but that's another reason. Hey, we don't have to worry about atmospheric monitoring if we don't use nitrogen, if we use something else. And I mean, that could be a safety concern for a lot of customers. Safety is the number one thing talked about, and not having to atmospheric monitor and where that nitrogen's going. If you just remove it from the equation, I would think that's a win for me.
Sure.
So
it's another factor to weigh in on there.
So if I was a water treatment rep listening to this and I'm intrigued, how do they learn more? Who do they contact as far as like trying to, I don't know, sell your products or get your products into their customers' hands or use their products in their treatment programs? What does that process look like?
They just contact me. They can go to our website and they can sign up to ask us to contact them. We have a part on our main site that says Ask Cortec. I think it might even be on the Cortec water treatment website. I don't have it right here in front of me to read that off, but it's and either way, there's a way to ask for that, and it would get forwarded to me, and or somebody on the water treatment team would be able to would reach out, and or my email address. If you include that on here, you can send me an email directly on there, and we'll what to do is set up. If you want to learn more, I can do a 20-30 minute training introductory overview, and I just to learn, and then it's a way of sharing what I have to offer, and also to learn more about what that individual rep is trying to do.
And then if you're an end user or a contractor and they want to learn more about these products, or they got a boiler layup coming up, they would ask their water treatment rep, or like how would they find somebody in their area that carries these products?
That's another good, really, really good question, and one that where it's what we're challenged a lot of times is if the end user contacts me, and we get contacted a lot of times because of the way our message gets out in the social media and other publications. I consider that the end user is going to pull our technology to their facility, either through their water treatment company who may or not know about us. It's an opportunity for me to meet that water treatment company, coach them on what our products are. If they want to they get set up to do it. If that water treatment company for some reason is not going to support their customer with our product line, then I'll get that end user in touch with somebody who will bring the product in. And it can be, there's a couple of different, what I call channels to market to the end user. We like to work with the water treatment companies because they own that process for the majority of the life cycle of that boiler. I think of boilers as, or any of the equipment that we've been talking about, it's in one of four stages or cycles, the cycles of operation. It's either running, it's not running, you're either shutting it down and you're starting it up, right? So if you think of that as that, it's running, you shut it down, it's out of service or idle, then you're starting it back up again. Well, the water treatment company is purely looking at the operating side of it. That's where their chemistry works. So if I can get them on board on how to use our chemistry for the rest of the cycle, the shutting down and the idling and the out of service, and then bringing it back into service, then they're able to bring that total integrated solution to their customer. as opposed to somebody else coming in and saying, well, I'm just doing the layup and he's doing the operating system. Then something happens and it becomes a finger pointing game. So trying to bring the water treatment coming in so they own it, they know how it works. But and that usually works. You're right. I would never call a water treatment service rep, dumb or ignorant about our products. It's a couple of things. Either their company has not brought our chemistry in, or their customers have said no enough in the past that they didn't really push our chemistry that much in other applications. Or the other part of it, they just didn't understand how our chemistry works. Like I said earlier, they were just hesitant to bring that to their customers' attention. But if an end user wants to know more about our product, we will talk with them, and then we figure out a way to get them in touch with the right company to help them bring that product on site. I got an example of a story of a water treatment company that he called me. He was out on the West Coast, taken over a new account, and they were coming at the end of their boiler operating season, and the customer manager said, hey, last year with that other company, they brought the boiler lizard in and laid the boiler up. Can we do that with you too? And the guy says, sure. Let me get some more information for you. So he left, went out to his car, and he Googled boiler lizard, found Cortec, then gave me a call and said, I had just told the customer I could get him a boiler lizard, and I had no idea what it is. So those companies exist out there. I mean, the water treatment companies. It doesn't mean they're not good. It doesn't mean they're bad. It's just that they don't know. And, the platform like this with you and those that are listening is for me, another way for them to hear about it.
Yeah, that's the biggest thing. I would say like everybody, most people think that we have an information problem, and it's the information is out there if you look hard enough, but most people either don't want to look hard enough or they just don't know where to look. And that's where the whole relationships thing, or being introduced to products, or even trade shows, like trade shows theoretically should be obsolete because the internet, they can find me on the internet. But if you walk past a booth and you're like, hey, we have this problem, and you walk past a booth and you're like, wait, they solved the problem and we didn't even know this company existed. And that's where like talking about the products and different solutions. And it's not that like people are once again dumb or uneducated, but
they're busy. They're busy.
Everybody's busy, and they only know what you know until you don't. Nobody knows what they don't know until they don't know it. And then, they hear a boiler lizard, and I'm sure some contractors out there thinking like, man, I wish, we had some simple solution like that. I need to get a boiler lizard to put in, that boiler, that we've been going around with this customer trying to get a layup, and, we weren't sure for this, or we weren't sure for that. That sounds like a great product. And it's been on the market for how long. And it just comes down to awareness, training, and getting different solutions in front of people, which is the name of the game.
And training is not one and done with any water treatment company. I do webinars and seminars just with water treatment companies. I do them with end users as well, but just introductory overview. And I talk about the comparison of what they may be using versus what our product offer. And one of the things I do ahead of time is a pre-webinar survey, 10 questions. But one of my questions is, have you ever heard, before the seminar or webinar, have you ever heard of or worked with a Cortec product? And it's consistently about 30% of the people that are going to come into that webinar have never heard of Cortec. And yet it's a company we've been doing business with for years, and I've done training with over a couple of different years. And you'd say, how do you explain that? World of water treatment, the turnover is 25 to 30%. People retire and they're leaving, they're going somewhere else, and you got new people coming in. And if they don't get it in their onboarding and training, then they're not going to know about it unless the customer asks about it. And then if that rep is worth their salt, they're going to start looking in and finding out what it is. When the customer's asking you about it, you better find out, right?
Yeah, that's the important part, is training. Training is something you do, not something you've done. There's no point where you can say like, yep, we've checked the box of training. Everybody's trained. We're good. And just go out there and sell and solve problems. It's
That's
this
right.
constant awareness. Even if you're a company and say, all right, we understand Layup, it's, hey, are there any new procedures? Hey, do we have any weird things? Maybe we have a boiler with some different metals in it or a different kind of heat exchanger or something. And is there anything on the product market for this or versus that? And it's having this awareness of, we don't know everything, but we want to always constantly be learning, which the internet provides great resources for. I think podcasts are for, this is a great conversation for people to learn. And I learn a lot from podcasts and this always be learning mindset of, I don't know what I don't know till I don't know it. And then I want to learn it. So yeah,
that's right. Yeah.
I had never heard of Cortec, and I've worked, not that I'm a water treatment person, but I've worked around water treatment companies and a lot of contractors and everything, and never heard of the boiler lizard till we had talked previously the first time. But now I'm like, oh, like that's a great product and so simple to lay up a boiler, or even the gecko or the dragon. Oh yeah, I think we covered it all. Is there anything else that you want to hit on?
I think that's we did. I think we did cover it all. I think it was great to be able to. I appreciate the chance to come in and talk to you like this, because it just takes one or two people listening to this that says, I've not heard about this, or they turn around and tell their customer and say, hey, you need to listen to this because this is what I've been talking about for the last couple of years. And now you can hear other people talking about why we should go this path on here.
Yeah, I just looked it up. Cortec has 41 videos on their YouTube channel. Yep, one of them is the corrosion. See the difference? VPCI, corrosion protection in action. Is that the video you were talking about
that
earlier?
Should be. Yeah, that should be. Yeah.
With the bottles, but look up Cortec on YouTube, Cortec Corporation. You will find it. They got a green, I don't know, plus sign logo. I don't know what that.
That logo is to get a nerd again on my nerd hat here, that's a positive negative charge that those molecules have when they're in that vapor, because that's technically what's happening is that molecule it either has a positive charge or negative. So when it is attracted to the metal surface, it's neutralizing that electrical surface charge. That's what takes out the corrosion potential. In addition, so that's a positive and negative symbol that represents that molecule in the air.
Got it. And I'll put a link in the description to the seasonal Layup products and then you'll see the boiler lizard and other products. And there's some PDFs there, SDSs, so that people can easily find those. And also I'll put your email address if that's all right.
Sure, absolutely.
When in doubt, contact Scott and he'll point you in the right direction and give you the answers or direction that you need. So thank you for coming on.
That's right. Thanks for having me.